Okay, so we're up to the last part of the continuous random variables, and it's the applications to word problems. So this example is straight out of the textbook. The length of time between calls to a helpline is a continuous random variable with the PDF defined by that function, which is exponential. Find to correct the for decimal places, probably the next call will come within 30 seconds, between 2 and 3, and more than 7. So what I'm going to do is just have a look at that, and then on the next page I'll show the diagram and show you what's happening. So just sort of absorb that and come across when you're ready. Okay, so I've got the formula, just make sure I've copied it down right. 0.6 e to the minus 0.6x. Okay, so I've got the formula written down right. So the sketch is exponential, it's decaying, so it's going to go backwards. So that value there, when x equals 0, e to the 0 is 1, so that value is 0.6. Okay. So in the first question, it talks about less than 30 seconds. So what this first question is what is that area? So that's the first question. In the second question, it's between 2 and 3 minutes. So the second question is asking for that one. Okay, that's the second one. First question, I'll change colours again. So that's the first question. And the last question is asking greater than 7. So the last one is what's this area here? Okay, so they're all areas, and those areas will be the probabilities. Okay, so let's go back to black. So first one equals the answer from 0 to 0.5 of function 0.6 e to the minus 0.6x dx. So the 0.6 can come out the front, and then e to the minus 0.6, e to the minus 0.6x divided by the coefficient, which is minus 0.6, between 0 and 0.5, and then that number kills that number, so we just got minus, and then we put the numbers in. So we got e to the minus 0.6 by 0.5 minus e to the 0, and you just put that in your calculator, and according to the textbook, that answer is 0.2592. So it's just straight calculator skills. Okay, in the second one, between 2 and 3, so we'll go straight to that second line. Probability will be, so we'll just go straight to the minus sign, goes out the front, because 0.6 and 0.6 cancel that every single time. So we've got e to the minus 0.6 times 3 minus e to the minus 0.6 times 2, close bracket. And again, just put that in your calculator, and you get 1,359. And the last one, the probability, we want bigger than 7, but we can't put in infinity. So what we're going to do, actually, we'll use the complement. So it's going to be 1 minus the probability that x is less than 7. So we can't actually do this because the upper limit was infinity, and we can't actually sub in infinity. So 7 to infinity is no good, so we'll do the complement. So we've got 1 minus, so we go straight to that answer. So we've got a minus sign, e to the minus 0.6 times 7 minus 0.6 times 0, because we're going from 0 to 7. And when you put that on your calculator, you get 0150, which you expect because it's a very small area. Okay, so have a look at those ones again if you need to, and copy them into your book, and come across. And there's no other example, but I say sketch the PDF, sketch the graph to represent the required probability, because even if you can shade in the areas, shade the areas that you're looking for, that's showing me that you know what you're doing. Okay, and second part is you always integrate. Okay, always integrating to find the areas. Okay, because that's the areas under the curve. Okay, and next thing is there's exercise. So 12D, page 601. So enjoy.